I'm not sure that it's intrinsic to its origins, within Aulacogen or the same kind of rift settings, but tabular granites are not strangers to rift settings or even other extensional settings as well. So
in an EB classification, are these A1? A1 is subduction modified, A2 is wave.
I think these are A2, but I forgot.
Oib?
Yeah.
OIB8.
I think. Don't quote me on that.
Well, we got a lot of data for the Carlton rhyolite on that. And the Mount Scott and the other granites in the Carlton rhyolite are real similar. And our rhyolite data straddle the OIB, Ocean Island Basalt Field, and they point towards continental crust. So I think that if you can believe those trace elements, I think there was a lot of interaction with crust. And it hasn't been shown in the isotopes yet because the sampling for the isotopes is so limited right now.
You need more isotopes.
Yes, definitely.
Anything about the crystallization temperature from zircon saturation or
zircon saturation? John Hogan did the calculations on that, and I'm remiss in mentioning John's work out here because he's still active and doing a lot of work. He couldn't be with us this weekend, but John was the postdoc with Charles when I was there and really fueled a lot of these questions for me. And John did the work on the zircon saturation temperatures in there. He got 950 for that. He had one other geothermometer that's escaping me right now, but
they like titanium.
I worked on a feldspar one. So the ovoid feldspars, they get to much lower temperatures. They're down in the 650s to 700s. And so there's a range of temperatures that you can find in this rock. I like to think that it's probably recording the crystallization history and cooling off of the granite, but there's still more work to be done temperature-wise to clearly understand how hot they are to come in and how that heat is removed.
It'd be a nice little focused project for somebody to tackle, see if they could get the temperatures for these different granites.
Oh yeah, I think so.
For the alkali feldspars, are they still sanidine in a northern place, or have they changed to some lower temperature form?
They're perthitic, so they're completely unmixed. And to sort of get a sense of their mixed chemistry, you have to back calculate from them. But perthite, of course, is the intergrowth of the sodic and potassic components in the feldspar. So it makes them look very patchy, and of course they're kind of altered quite a bit. Some are fresher than others. The ones up here are going to be strongly altered by weathering and other phenomena in the near surface. So they get messed up pretty easily. But you get a flavor for what the rocks were really about as crystals from the magma.
So
right?
no anorthoclase.
No anorthoclase.
So
yeah, no, actually it gets...
but it would have been, it's a mix. All they have is
They're microperthites, right?
They're microperthites, that's right.
So
but some of the ovoids, when you reassess the bulk composition from the perthite, you get fairly sodic composition. There's really two populations of feldspar phenocrysts.
Has anybody done any uranium, helium, uplift ages on this stuff?
Not that I'm aware
Wide
of.
open, huh?
It would be nice.
I mean, one of the arguments is this Permian relief or is this paternal relief?
I knew you were going to bring that up. I am going to stick to the party line on this because I'm a fan of it, but one of the arguments that Charles likes to make about this is you've got the Mears Valley going this way, but Little Medicine Creek cutting down through the granites and rhyolites, which is, not ideal in terms of stream geometry. So we need to dial the Wayback Machine and think about what's happening here to get us to this point. So we've been talking about the Aulacogen and the Cambrian and thinking about the magmatism there. And we also alluded to the fact yesterday that we're getting to see all this stuff because in the Pennsylvanian we have appreciable uplift of these materials, exposure to the surface. We might point it out on the north side that just beyond the Slick Hills you've got one of the deepest basins in the world. So you're on the upthrown block of this Pennsylvanian collisional tectonics that has brought everything up here. And we discussed a little bit better yesterday about strike slip versus thrusting to get this. I don't really have anything to speak to that here. But we have these here because of that, and of course what happens next is you've got mountains, so they start to become buried in their own detritus. We got the Ouachitas to the east. We're getting influx from those. The big inland seas are to our west. So the streams that are coming down here in the Permian, particularly during the Leonardian, are likely to bury all of these features. And we can certainly go to the west and see the Permian stratigraphy that would likely cover this. And the horizon for the top of the Permian as you go into the Triassic lines up relatively nicely with what our elevation here is on Mount Scott, with a little bit of alteration. So the thinking is, and this is sort of the Charles Gilbert party line that I'm espousing, is that these things were buried during the Permian and maybe a little bit during the Triassic. There's no evidence of Cretaceous cover in this area, but the inland sea is pretty extensive.
Up in the Anadarko there's some.
Yeah, that's true. And then we basically uncover it to get to the current exposure. That would make this fossil topography. In other words, I actually have a poster on my door in my office, which is a picture of the front of the Wichitas from about Mears, and I have a Dimetrodon wandering around the post oaks, because that's the way I view it, that basically this, you're looking at a Permian landform here, you're looking at Permian features. But I think Bob actually has some other ideas about how much...
Oh yeah, so if you believe this is exhumed Permian topography, you're welcome to that notion, but to me, knowing the Mears Fault is there, seeing Turner Falls, which is clear evidence of recent tectonic activity, what we see here is evidence of very recent uplift, and we now have the tools to evaluate it, we being the community.
Right.
And we simply need to try and get those people up here to attack it. They've got 1,000 feet vertical that they can play with.
Yep.
There's no, to me, I look at this and I go, there's no way this has been sitting around 250 million years.
No, I was saying it was buried and then...
Well, but it may be partly exhumed Permian topography.
No, we know that there are Permian conglomerates lying on top of parts of these, but we never see a very thick section anywhere on top of these. So you have to say
It's eroded
all
away.
of it has been.
That would be the
all
argument.
of it's been taken.
Now, contrary to that, if you look in your guidebooks, there's a paper by Doug Elmore and co-authors that worked on the Long Mountain and the history of alteration on that using PaleoMag, and they get a clear Permian signal for the reddening of the granite there, which I think is curious. Certainly, I would strongly argue that a lot of the characteristics you do see here have some kind of influence in the Permian from some aspect, because it does leave an imprint on these rocks that is very Permian in nature. But the degree to which, this is fossil topography versus very recent activity, I think we can answer those with some of the newer tools that deal with that. And,
Well, we go down the K-Tone overlook here. You're standing on a Permian alluvial fan,
right,
with boulders this big, and that alluvial fan is pointing right up to this mountain. I mean, you're seeing an alluvial. If you're standing on that alluvial fan, you're standing on the Permian timeline. And so you're standing on that Permian timeline and you see the Mount Scott in front of you. So I think a lot of the topography was Permian, because you're standing on an alluvial fan right there. And so I think there was a lot more alluvial fan stuff that had gradually blanketed it all. It's gone now. So you say everything's eroded. No, it's not. It's eroded down to where it still is.
Yeah, there's certainly the granite wash, which is Pennsylvanian age. So there were granite exposed and washing into the Anadarko Basin.
Yeah, thousands.
Please say
of granite
Arcos.
wash. But, there's another interesting story. I don't know. A number of years ago, there was a paper, I think in Journal of Geology, where they came out here and they just looked at the fact that a lot of the peaks are more or less at the same elevation. It's like an erosional surface we're kind of standing on.
Yep.
If you project this over to Elk Mountain, which is pretty flat over that way, and what they did, graphic with computers, they projected that surface and to the west, and it hits the high plains in West Texas and going up, and it hits the high plains where this sheet, the Ogallala, mild Pliocene, this massive alluvial fan that was shut off when the Rockies were being exposed by a pyrogenic uplift. So what we're standing on here, according to them, that surface projects with the where the Ogallala is resting on top of the high plains.
There was another paper that does the same thing, but it points out some benches over in the western part of the Oklahoma Ouachitas. And they claim that the benches, the low-lying benches, are an extension of the Ogallala surface. So there are definitely two opinions of that geomorphology.
But what they're saying either way is probably the Ogallala covered this area.
Yes.
And that,
maybe not this far east, according to the other, but
Well,
Yeah,
but
it's debatable.
you know, so I'd got my BS and Masters at Oklahoma State, and what you could see out there sometimes, you wander around in the prairies out there, you see these big pebbles and cobbles of chert and quartzite and stuff like that. And we were always taught that that was actually relic material that was left when the Ogallala had made it all the way over there. Everything had been stripped away, and those really resistant chert and quartzite cobbles just kind of always got let down, so they're standing loose on the prairies out there. I don't know if
Is
it's
that
still
as far
true.
east as Stillwater?
Yeah, I think as I remember.
Has someone
Fascinating.
collected those and compared them to the Ogallala?
This is
And we saw the same thing in our mapping in the Oklahoma City area. You're out in the middle of a
Yeah.
farmer's field, it's
Yeah.
all red dirt, and here's a Rocky
Those
Mountain
gravels.
cobble.
Yeah.
So there's some evidence that that vast sheet of Ogallala material went way far east.
Tom Lehman is picking apart the Ogallala, so if people have samples, you might contact him.
We're talking about mid-Permian or end Permian?
Lower Permian.
Lower Permian.
So we're in the rocks around here are Leonardian stage, and you don't really get much further out of that by the time you get to the high plains. You have an unconformity with the Mesozoic out there, so you don't get far enough up out of the lower Permian in this area.
Hey, John,
Yeah.
at this rate, we will complete our circuit by 1:30.
Okay.
So how, I mean, you saw.
Do you want to say something quick about the rhyolites before
Oh,
we
you
get
better
going?
say.